Hey guys, lesson 2.8, graphing inequalities. Our learning target for this lesson is being able to graph and read the solution to a single variable inequality on a number line. Let's go ahead and dive right in. As always, please attempt to work through the example before continuing the video. Please press pause to give yourself as much time as needed to work through an example and or to copy down definitions and other notes. Let's begin. Please take a moment to complete the warm-up. Go ahead and press pause to give yourself plenty of time. As we work through the warm-up, we know that in part A, the temperature T for the day ranged from -3 degrees to 12 degrees. Here we can take a look at a double inequality. Our double inequality should range from -3 to 12 degrees, and we are dealing with a temperature T. Therefore, we can place our temperature T in a double inequality between 12 degrees and -3 degrees. As we take a look, the T definitely has to go in the middle and the symbols should be facing in the same direction. In this case, I chose to include the -3 and the 12 by including the or equal to symbol because the temperature did range from -3 to 12, so I assumed that that meant to include -3 and 12. Part B says there are over 2 dozen cars in the car lot, but not as many as 3 dozen cars. Right here, this keyword over 2 dozen tells me that 2 dozen is too small. So I know that 2 dozen or 24 should be less than the number of cars in the lot. And it says not as many as 3 dozen. Therefore, I know it should be less than 3 dozen or 36. Next, it says he has less than $125 in his bank account. I know that the number of dollars he has is less than, not equal to, but less than 125. If you did not get these 3 inequalities, you might be starting to think about why you missed them and perhaps writing yourself a question mark over here during the warm-up or the practice to make sure that you do ask a question at the beginning of class next time. Moving on, we are going to go ahead and take a look at some background, some vocab for today's lesson, or just a few reminders about number lines. When we are graphing on a number line, to graph on a number line is to graph the dot actually on the number line. So as we take a look here, if I wanted to graph, say for instance, a point A that is equal to 3, I would actually find 3 on the number line and graph it right on the number line. A graph just means that I'm coloring a dot right on 3. I might be asked to graph a point B, which is equal to -2.5. At this point, I'm going to look between -2 and -3 on my number line, exactly right in the middle. And again, I'm going to graph a nice dot right on that number line. This is just a reminder that the dot goes on the number line, not above the number line or below the number line. Another example, if I wanted to graph the point C being equal to 0.1, this would go directly on my number line, somewhere between 0 and 1, quite a bit closer to 0, maybe about right here on my number line. So the dot goes directly on the number line. That's important for us to remember. Now I want you guys to go ahead and try sketching a number line in your notes and graphing several numbers that fit in the following inequality. N is less than 6. Go ahead, take a moment, press pause, sketch the number line itself, as well as graphing a few numbers that fit in the inequality. Hopefully you have now taken some time to graph some numbers that fit into this inequality. I am actually going to take a look here at some possibilities. You may have used one of these possibilities, or you may have chosen another one. Here it says that N is less than 6. I could choose a number like 2. I could choose a number like 5.5. I could choose a number like, I don't know, -2. There's a lot of different numbers that we could choose to graph so that it fits N is less than 6. We could have chosen 0, -5, -4.5, 1.1, 0.5, negative 1.5. We've got a lot of different options that we picked. We are limited in some ways, though. We didn't want to pick any numbers that were larger than 6. We didn't want to pick anything to the right of 6. Today our job is to be able to quickly, without drawing individual dots, graph all of these numbers that would in fact fit less than 6. We want to make sure that we can draw them all quickly and easily to identify them rather than making dot after dot after dot after dot after dot, because as you could see, that could take quite a while. We want to make sure that we've gotten them all down. So today we're going to talk about how we can make sure that we do that on a number line. If we take a look here, there are basically 5 steps to graphing an inequality on a number line. Step 1, graph at least 3 solutions that you know work. This gives you an idea of what you're looking for. Step 2, circle the boundary points. These are the numbers that separate the true from the false. In our previous example, this would be the 6. The 6 here separates the true from the false for us in this example. That's what we're comparing everything to, is a 6. Again, that is called a boundary point. Step 3, decide if the circles should be shaded, which would mean they are included. Yes would be if we are going to say equal to, no if not equal to. Shade the proper area of the number line. This should be where your 3 solutions are. In step 5, we always want to label the number line so we know what we are using the number line to describe. So if we go ahead back to what we were just looking at, and you don't have to write this one down, you can if you'd like to. We're going to identify that number that separates the true from the false. That's called our boundary. It separates the true from the false. We would want to go ahead and circle that. Now that circling looks a little bit big. I am going to actually remove that so we can see that it is really a circle. So if we take a look, we want to circle the 6 on the number line because this separates the true from the false for us. What that does is it kind of draws a border between the true and the false. If we take a look, we were getting pretty close with our 5.5, our 5.9. We want to make sure that 6 is isolated as its own spot. This is the separating the true from the false. If we take a look, after circling that boundary point, we decide, should that be shaded in? Should that be identified as a possibility? And in this case, if I try out a 6, 6 is less than 6. This is not true, so I do not shade this in. I'm going to go ahead and leave it open. Fourth, we were to shade the proper part of the number line. In this case, the proper part of the number line is left of 6 because these were the values that work. Now this is where things get tricky. We come to the end of our number line. It seems as though it may be the end of our solutions. However, numbers that would be on the other side of this arrow are things like negative 1 million, which of course would work as well. So we show, just like we do the number line continues, that our shading continues by shading an arrow here. And last but not least, we give the number line a label. It goes on the lower right hand side here. We are identifying possible values for n on this number line. And that's it. So this is using an example that we've already done. I did not require you to write this down, but we're going to go ahead and take a look at a couple that you should write down now. We're going to graph all solutions to m is less than or equal to 0. First thing that we're going to need, of course, in order to make a graph of all these solutions is a number line. We need somewhere where we can write down all of our possibilities for m. So I'm going to go ahead and sketch myself a number line here. I've got a nice tool that'll help me make a somewhat straight line. I need to add in the tick marks. Now, your number line can start and end anywhere you'd like. In this case, there is one number that absolutely has to be on it, and that is our comparison number, our boundary number, the 0. That can go anywhere we'd like. Some people like to put it right in the center. I usually like to put mine off a little bit. Maybe over here I can identify my 0. And I want as evenly spaced as I can. Tick marks. Each of these tick marks will represent a number for us. That number will depend on the scale that we choose for our number line. Some people like to count by ones all the time. I like to switch things up a little bit and perhaps count by twos. So if this is 0, to the right would be 2, 4, 6, and my number line continues with numbers like 8, 10, 12, and so on. To the left would be -2, -4, -6, -8. You'll notice I'm only writing in every other number on the number line. It is not necessary to write in every number. It gets a little cluttery if we do. Just like to write in every other, sometimes every third number is written in. Here I can see that M, ooh, that's a good idea. We can write down what we're going to be showing on our number line right now. M is less than or equal to 0. I'm going to go ahead and think of something that will work here. Something that might work would be something like, ooh, -5. -5 is less than or equal to 0. I'm going to go ahead and graph -5. I know that another number that would work would be -10 is less than or equal to 0. Right over here. Another one that should work is -1 is less than or equal to 0. Sensing kind of a theme here. It looks like most of our answers are negative, most of our possible solutions. The boundary point in this case, the one that we are comparing everything else to, is 0. This is going to separate the true from the false. I have to decide whether or not this should be colored in, and one way that I can do that is by testing 0. Is 0 less than or equal to 0? And in this case it is, so 0 should be graphed as a possible answer too. So I do shade this in. The proper area of my number line that should be shaded is where my other solutions are, right here on the left. Again, the end of my number line does not mean the end of the possibilities, so I create and shade an arrow as well. In our next example, we have not a single inequality, but a double inequality. Things haven't changed. We're still going to start by creating a number line where we can graph our possible solutions for W. Remember, solutions are the values that can replace the variable to make a true sentence. So we're going to go ahead and start off by creating our number line. Taking a look here, it looks like the numbers that are a part of my inequality are -1 and 6. So my number line really can contain any numbers as long as it contains both 6 and -1. In a double inequality, it's really helpful the way it's set up, because in the double inequality, W is right between 6 and -1. All of our possible values will be right between -6 and 1. So go ahead and label your number line so that you can see both. So we've got a good number line here. Our job is to find at least 3 values that fit. Kind of taking a look here, it looks like I have graphed 0, because as I take a look, the W could be replaced by a 0. We can also see that 0.5 has been graphed, because 0.5 would fit in the inequality as well. 6 is greater than 0.5 is greater than or equal to -1. We can also see that 2.5 has been graphed on our number line, because if we try 2.5 in place of our W, 6 is greater than 2.5 is greater than or equal to -1. When we are looking for our boundaries in this case, we are looking at -1 and 6. These are the numbers that W needs to be compared with. W should be in between these numbers, but we have to decide if 6 or -1 should be included. And in this case, we would want to go ahead and include -1, because -1 is a valid solution. We do not want to include 6 though, so we'll just go ahead and leave that as an empty circle, meaning that we're going to get all the way up to 6 but not include it. And our final example, reading a graph. In this case, we need to decide what the shaded portion of this number line represents. One thing's for certain, we know that it is representing possible values for Q, because it is labeled with a Q. If we take a look, the boundary points that have been identified are -7 and -1, and Q is directly in between those boundary points. So in our double inequality, we will put Q between our boundary points. In this case, we know that Q is going to be greater than the -7 boundary point and less than the -1 boundary point. We can also see that -1 has not been included, so we do not need the or equal to. -7 has been included, so we do need the or equal to. This is a great way of taking a look at a number line and how we can identify what the number line represents. One final slide for us today is a check for understanding. You should make an attempt to graph each of these. We will discuss them in class next time I see you. Have a great day.